In this video, we're going to try and find the local extreme values of this surface. So if you get a graph plot and plot it, it will look like this. So we are trying to find this point here, the lowest point. Remember, in reality, you would be given this. You won't be given the graph. So you don't know it concaves up. It could concave down. Let's pretend we didn't know it concaves up. But it could concave down. It could be a saddle. So in the previous video, we've seen that if you are truly at the lowest point, then fx equals 0, fy equals 0. In the previous video, we've seen that if you're truly at the highest point, then fx equals 0, fy equals 0. And if you're at a saddle, then fx equals 0, fy equals 0. We've already seen this. So to find the critical points, we need to demand that fx equals 0, fy equals 0. So the first task is to find the critical points. In our case, there's just one point. So we need to find fx. So looking at this, differentiate it with respect to x. That will then give us this. And then partially differentiate this with respect to y. That will then give us this. We need to demand that this equals 0 and this equals 0. So we need to demand that this equals 0 and this equals 0. So x and y equals this. So what that means is this. Hang on. What that means is that the lowest point is at -4 and +3. That's the location of the lowest point. But remember, we don't know, because we cheated. We know what this looks like, but in reality, we won't be given this. So we just know that there's something fishy going on at -4 and +3. We don't know if it concaves down or if it concaves up or if it's a saddle point. We just don't know. But here I've given you a simple case where we can cheat. We can complete the square on this. So complete the square on this. So remember, this is high school stuff. So complete the square on this. That will then give us this, and then carry this down, and then merge all these constants together. That will then give us this. You see, at the moment, we know that there's something fishy going on at -4 and +3. By completing the square, it took us to this. So we know that looking at this block here, the lowest that this could be is when you put -4 in here. The lowest that this block could be, because when you square something, this block can only be positive. The lowest that it could be is when you put a 3 into the y. If you put anything else, then you're going to make this block bigger, and you're going to make this block bigger, making the whole thing bigger. So by completing the square and getting it in this form, you know that you are at a local minimum. You are at the lowest point when you put -4 and +3 in here. Anything else would make it bigger. So anything else would make it bigger. So you know you're at the lowest possible point. So in general, if you're given us a surface, you've got to find the critical points. Once you've got the critical points, you well, in this case here, we can complete the square. I've given you a simple case where you can complete the square, but in reality, you don't know if it concaves up. In reality, you won't be able to. You won't always be able to complete the square. But I've deliberately given you an easy case where you can complete the square. So once you've found your critical points, in the future, there are some tests that we can do in order to establish if it concaves up or if it concaves down or if it's a saddle point. But for the time being, we're going to leave that for the time being. We're just going to complete the square and then realize that, oh, we are at the lowest point. But in the future, there are some tests that we can perform to establish if our critical point is at its maximum or if it's at its minimum, or if it's a saddle. Okay.